A game costs 50 pence per turn. It consists of 3 windows, each of which can show a tennis racket, a hockey stick, a cricket bat, or a golf club. Each window works independently of each other. The probability of each sport equipment shown is given by the probability of a tennis racket being 0.3, the probability of a hockey stick 0.2, and the probability of a cricket bat equal to 0.4, and the probability of a golf club 0.1. The winning combinations are shown on the right, calculating the expected loss or gain. So if you get a golf club in 3 windows, it's £2.50, a hockey stick in 3 windows, £1.50, tennis racket in 2 windows, and a hockey stick in 1 window, £1, and a cricket bat in 3 windows, 60p or £0.60. Okay, so if we let x be the random variable, the expected loss or gain, so if we now work out the probabilities of each winning combination, so the probability of the golf clubs in 3 windows is just going to be equal to 0.1 cubed. Okay, so 0.1 times 0.1 times 0.1, and that can only happen one way. That's equal to 0.001. The probability of a hockey stick in 3 windows, so a hockey stick, the probability of a hockey stick is 0.2, so it's going to be 0.2 cubed, so it's 0.008. And then the probability of a tennis racket in 2 windows and a hockey stick in 1 window, well, that's going to be equal to the probability of a tennis racket is 0.3. Okay, we'll just look. Okay, so 0.3 squared times 0.2. But what we've got to remember, these can happen 3 different ways. We can have tennis racket, hockey stick, tennis racket, hockey stick, tennis racket, hockey stick, tennis racket, tennis racket. So if we work that out, we get 0.054. Okay, so writing all those down again. And a cricket bat in 3 windows is 0.4 cubed, which is 0.064. So if we write all these probabilities down of each of these winning combinations from what we've already learnt, we can now work out, now the probability of not winning will be 1 minus all of these. So 1 minus 0.01, minus 0.08, 0.054, minus 0.064. That will be equal to 0.873. And now we can write these in writing the probability distribution table. So make a table, so don't forget X stands for the expected win or loss. So we can lose 0.5 because that's the cost of actually playing the game if we don't win anything. Now this becomes 2, not £2.50, because it costs 50 pence to play the game, which is not going to be given back. If it is given back, then that needs to be £2.50. 1 for the same reason, 0.5 for the same reason, and 0.1. So putting in the probabilities, and now we have our table. Okay, notice the sum of all these probabilities is equal to 1. Right, so writing out our table again, quickly. Right, now we can calculate the expected loss or gain, okay, by doing minus 0.5. So that's called E of x, the sum of all x times the x times the probability of each one. So that's going to be equal to minus 0.5 times 0.873, plus 2 times 0.001, plus 1 times 0.008, plus 0.5 times 0.054, plus 0.1 times 0.064, which is going to be equal to minus 0.39. Therefore, the expected loss per turn will be 0.3 i.e. 39 pence would be the expected loss. Okay, so this has been a video to show you how to calculate the expected loss or gain in a game. I hope you've understood, and I thank you very much for watching, and maybe you could consider subscribing to my channel. Thank you very much. The website of my videos is in the notes of the video.